Before recording a study, you should set up the manometric perfusion pump, ensuring that all channels are filled with water and are perfusing, preferably with the catheter attached and placed in a bowl of water. Ensure that you have a recent calibration file available. To record data, click on Record Manometry in the main menu screen. This will take you to a screen that asks you to locate a calibration file to use. Note that the calibration file name contains the date and time that it was created to help you identify the most recent calibration. By default, the files will be sorted by date. Select the appropriate calibration file. Generally, this will be the most recent file. Either double-click on the file name or select the file and then OK. You will now be asked to locate the patient on whom the study is being performed. If there is a long list of patients, you can type some of the patient's name into the Search For box at the top, which will show all patients with that combination of letters in their name. To clear the search box, click on Show All. If the patient has not had their details entered, click on Add New Entry. Enter at least a surname, forename and date of birth. The other fields are optional. However, if you enter a patient identifier into the UR field, that number will appear on the report. Click on OK to return to the patient selection screen with the new patient selected. Double-click on the patient name or click on Select this patient. You will then proceed to the main data recording screen. In this screen, the data being recorded is scrolling across the screen in the large graph. This is a pressure topography plot. The x-axis represents time and the y-axis represents the position along the catheter, with the actual sites of the recording points indicated in the vertical black bar on the left of the graph. You can see that the catheter has a high resolution zone at its lower end, where the channels are spaced at 1 cm intervals. This is intended to be placed across the lower esophageal sphincter. Above this, channels are spaced at 3 cm and are intended to record from the body of the esophagus. The z-axis or colour represents pressure. The colour scale can be seen to the right of the graph. Note that 0 is white, negative pressures are blue, and positive pressures are greens, yellows, browns, pinks, reds, greys and black. To display a conventional line plot with the pressure values for each channel at the right hand end, click on the pull down menu beside Colour Plot and select Line Plot. This graph shows a series of line plots, one for each channel. The pressure values being recorded are shown at the right hand end of the graph. The pressures recorded will initially be relative to the 0 values recorded during the calibration. So if the catheter is perfused at the level of the perfusion pump, they should be slightly positive. Because of hydrostatic effects, if the catheter is being perfused below the level of the perfusion pump, as in this case, they will be negative. The pressures should be fairly consistent between channels. They may vary by up to 20 mm of mercury. And when all of the air has been perfused out of the catheter, they should be stable. The next thing you need to do is to reference all of the channels to atmospheric pressure to remove the pressures required to perfuse water through the catheter channels. This must be done before each study, with the catheter perfusing underwater in a bowl placed at about the level the patient will be during the study. Clicking on Set Ref for all selected will set the current pressures in the selected channels, all are selected by default, to 0 mm of mercury, which will now be recorded as atmospheric pressure at that level. A marker will be inserted in the recording, indicated by a vertical black line on the display. In the colour plot graphs, you will see the background colour change to white, indicating that the pressures are now 0. And in the line plot graphs, you will see the current values at the right hand end change to 0. When the channels are perfusing and stable, the background should remain a constant colour, preferably white. If there is some drift in a channel, a blue or green line will appear horizontally on the screen at the level of the channel. If there is some drift in a channel, you may need to flush the channel and can re-zero the catheter by pressing F1 on the keyboard to make the pressure reference button visible. Then press the button again, as has been done in the centre of this screen. A marker will be inserted and the background colour will return to white. The reason that the button disappears after you have pressed it is that inadvertently performing an atmospheric reference during a study will have a major effect on the data, and the button disappears to prevent it being accidentally pressed. You can check that all of the channels of the catheter are perfusing and that the calibration is correct by lifting the bowl up 50 centimetres or so. This should induce a pressure rise of equal proportions, that is, the same colours, up to about 40 millimetres of mercury in all of the channels. If one channel is not perfusing or is incorrectly calibrated, it will not change colour with the rest. The next step is to position the catheter in the patient, with the upper sphincter at the top of the colour plot and the lower sphincter in the high resolution zone of the catheter at the bottom of the plot. Pass the catheter through the nose into the stomach to about 50 centimetres and secure it at that point. In order for the display to look right, you will now need to set the baseline pressure to intragastric pressure. The background pressure will be set to the instantaneous pressure in the selected baseline channel, and will be subtracted from all pressure values to correct the colour display so that the intragastric pressure becomes 0 millimeters of mercury or white. The value that is currently used as the internal baseline is shown to the right of the Set Baseline button and can be changed manually if you wish, but generally you will just set it by pressing on the Set Baseline button. If the screen is a peculiar colour, very positive or negative, it is likely that the baseline has been set to an incorrect value, such as during a cough or artefact in that channel. You can reset the baseline by pressing on the button or adjust it manually in the control. Unlike setting the zero reference pressure, setting the baseline does not change the data that is recorded. It only changes the screen representation of the data. You can therefore change the baseline as many times as you like during the study, and in fact will need to reset the baseline whenever the patient changes position. You will see the upper sphincter as a band of pressure at the top of the screen and the lower sphincter as a band of pressure at the bottom of the colour plot. Peristalsis creates a diagonal band of pressure travelling from the upper to the lower sphincter when the patient swallows. Make any final adjustments to the position of the catheter. The most important factor in positioning the catheter is that the lower esophageal sphincter is within the high resolution area of the catheter. If the lower sphincter is difficult to see, ask the patient to swallow, which will cause a post-swallow augmentation of the sphincter pressure. To locate the diaphragm, ask the patient to breathe deeply, which will make the intrathoracic pressure more negative, that is a deeper blue, and the intra-abdominal pressure more positive, that is a deeper green. You will also see the pressure increase at the level of the diaphragm, and the diaphragm will descend. If a channel is not displaying correctly, you can turn it off in the Channels On control at the bottom of the screen. But obviously this indicates a problem with the perfusion or the catheter and should really have been sorted out before the study began. If you turn a channel off, the catheter representation changes, with a red line appearing in place of the white line at that level to show that the channel is turned off. Once the catheter is correctly positioned, you need to adjust the depth of insertion control on the screen in order to ensure that the scale along the left-hand side represents the distance from the nose. The depth of insertion can be read from the markings on the catheter, and the depth of insertion control on the left-hand side of the screen is then adjusted to correspond to the number read from the catheter, which represents the distance from that point to the most distal recording point on the catheter. For example, If you can see the 57 cm marking at the nostril, the depth control would be adjusted to read 57. Each time you change the depth of insertion control, a marker will be inserted, and a vertical black line on the recording will indicate this. You can adjust the depth of insertion control either by selecting and entering the numbers directly, or by using the arrows at the side of the control. Note that the numbers along the left-hand side of the colour plot graph update to reflect the change. You are now ready to start the study. Initially, you will record a basal period. Position the patient and instruct them to swallow as infrequently as possible for the duration of the basal period. A few minutes is usually sufficient. You can select the basal period marker from the pull-down menu or enter the text directly into the marker box. Click on Mark Now to enter the marker. A vertical black line appears to confirm that the marker has been saved, and the marker counter on the left-hand side of the marker text will increment. After the basal period, you'll perform a series of swallows. Again, use the pull-down menu to select the type of swallow. Then click on Not Counting, which will change to Counting, and a number will appear after the marker text. Now when you click on the Mark Now button, a marker will be inserted and the number will increment. If you wish to see the markers that you have already entered, click on Show Markers to display this in the upper left-hand corner. If you enter an incorrect marker, press on the Trash Marker button and it will not appear in the analysis. To clear the marker text box, click on Clear Marker Text. You can enter free text into the marker box if required, then press on Mark Now to save the marker. At the conclusion of the study, remove the catheter from the patient and place it back into the bowl of water for another period of underwater recording. This is to check for and allow later removal of any pressure drift that may have occurred. Data is saved in 30-second periods. The red and green display in the bottom right-hand corner indicates the current position within each 30-second data period. If you click on Press to Stop, the button will change to stopping, but recording will continue to the end of the current period, then cease, and you'll be returned to the main menu screen. If you need to restart a study with the catheter still in the patient, after for example a computer crash, and you select the same calibration and patient files, you'll be given some options as you start up. The first asks whether you wish to create a new data file for the patient or append to an existing file. If you are continuing a study, you should elect to append to the existing file. The second asks whether you wish to use the original calibration offsets or the last offsets. If the catheter is in the patient, you should elect to use the last offsets, that is, the atmospheric reference pressure points recorded during underwater perfusion prior to insertion of the catheter into the patient. If you use the original calibration offsets, this will load the values for the 0 points set during the calibration, and will be the same as performing the study without referencing the atmospheric 0 pressures. If the catheter is not in the patient, generally you should elect to start a new study and perfuse underwater in the usual way to set the atmospheric 0 reference pressures.